Welcome back. In this video, we're going to explore the concept of a slope field. The slope field is an extension of the differential equation, and what slope fields do is they're going to take a derivative, things like this, like dy dx equals y, and what I'm going to do is I'm going to plot little line segments, whatever the y value, in this case the y value equals. So the y value is 1, I plot a line segment, that's 1, 2, so on and so forth. If I have one that dy dx is x minus y, then I got to plug in the ordered pair. So like if I plug in this ordered pair, like for instance, if I plug in this ordered pair right here, 1, 1, I have a slope of 0. So I sketch a line segment that has a slope of 0. If I plug in this one up here, that would be 1, 2. That has a slope of negative 1. So I'd sketch a line segment that's a slope of negative 1. My first example here, I'm asking you where would I have vertical line segments when y equals what? Well, I'm going to have vertical line segments when the denominator is equal to 0. So 4x plus 2y equals 0, or 2y equals negative 4x, so y is negative 2x. So whenever y is negative 2x, I got vertical line segments. In my next example, I have a derivative negative y over x squared, and I give you this point, negative 1, 3. So if you were sketching the slope field, you would sketch a little line segment through that point that has a slope of what? So you're going to plug in negative 1, 3, so it would be negative 3 over negative 1 squared. That's going to end up being negative 3. So through that point, you would sketch a little line segment that has an approximate slope of negative 3. Now, how I combine that stuff with the differential equations are things like this, where I have dy dx equals y minus 1 squared times cosine of pi x. The first part is they ask you to draw this slope field. So they draw the slope field. So that's the slope field that they drew. Then they're going to use that information. They say as a horizontal line equation, y equals c. And where does that occur? Well, that occurs right here at y equals 1. So you can use your slope field to help you. And then finally, the last part of it, this is the solving the differential equation that we've been doing. So if I do this, if I separate the variables, I get 1 over y minus 1 quantity squared dy equals the cosine of pi x dx. And now, let me get a little bit of room. I'm going to go ahead and integrate that. And when I integrate that, I integrate both sides. On the left-hand side, it's just power rule, so it's going to be negative 1 over y minus 1. Here I've got to use u substitution. That's going to be equals 1 over pi times the sine of pi x plus c. I'm then going to use this point at 1, 0, so it's going to be negative 1 over 0 minus 1 equals 1 over pi times the sine of pi plus c. Sine of pi is 0, so the c value is just positive 1. So again, solving it gets to be a pain. It's the negative 1 over y minus 1 equals the sine of pi x over pi, and it's going to be plus 1. So now I got to do a couple of things. First of all, I'm going to do this addition right there. So I'm going to write it as the sine of pi x plus pi over pi. If you multiply both sides by negative 1, this just becomes negative. That becomes positive. And then if I flip it over, I want to take the reciprocal of both sides. So y minus 1 equals negative pi over the sine of pi x plus pi, and then move that 1 over, and it's plus 1 there. And then my original equation would be y equals negative pi over the sine of pi x plus pi plus 1. Sometimes they'll give you things like this, where they give you this derivative, which is the derivative is the cosine of x, and they'll ask you which one is the slope field. The sine, if you look at this, the cosine of 0 is 1. So if I look just along the y-axis, like for instance, this could work because those segments are approximately 1. That's not going to work. Those segments are 0. Same here. This one, oh, that's also 1. So A and D could work. E is negative 1. So the only choices I have are A or D. Which one is it going to be? Now, if you just look at the general shape, this looks like cosine. It goes up and then it goes down, so on and so forth. This one does not, because this like goes here, it flattens out, and then it keeps going up. So it's got to be A. So sometimes you get things like that. And then also sometimes you'll get a slope field like this, and they'll ask you which derivative it is. Anytime you can simplify the derivatives, you should simplify it. So this would be like x times y plus 1. This one would be y times x plus 1. The other two do not simplify. And then look for any patterns. Like for instance, in this one right here, when y is -1, that derivative is 0. So this could work. That's a possibility. Okay, that's not a possibility, so that does not work. That could work, so that's a possibility. That does not work. So I just got to compare A and C, and I got to go to another quadrant to take a look at that. I would go to somewhere where the x value is going to be different. So I would go to like the second quadrant. So like if I choose a point over here, if I were to choose a point over here, like let's say I choose this point right here, which is going to be at -1, +1, okay? -1, +1, that would end up having a negative slope because of that -1 right there. In this particular case, that would not. That would have a positive slope of 2. So since this has a negative segment, or negative little line segment, it's got to be A instead of D. Slope fields generally are not the hardest part of differential equations. Sometimes you got to use a little bit of process of elimination like our last example there, but besides that, should be pretty good to go. See you in class.